All right, 6-1 is ratios, and I've got a little note out here. So on your paper, I want you to write the word simplest form equals improper here, okay? And the reason I want you to write that is because in previous chapters, when it has said write it in its simplest form, we always turn it to a mixed, and that's the correct thing to do, okay? Simplest form equals improper. Yep. Or I wrote improper is good because I wrote that first hour and I was actually saying it's good to write it, to leave it as an improper, but. And here's why, okay? And this is the example I used first hour. If I have, and of course Halloween must have been on my brain because I used M&Ms and Kit Kats. So if I have 10 M&Ms for every 3 Kit Kats, right? So that's M&Ms over Kit Kats. I want to leave it like this because if I turn this to an improper, now I don't have a ratio anymore. A ratio is a fraction, something over something, and it's M&Ms over Kit Kats. Well, if I write it as a mixed fraction, I have now mixed M&Ms and Kit Kats into some weird candy that I'd probably still try it. I'm not lying, but it's not M&Ms over Kit Kats anymore, right? It's this mixed conglomerate thing that doesn't tell us anything about the ratio. So when you're dealing with ratios, and this is where I want you to keep it straight, because when you're taking iLearn, if you're given just a plain math fraction like our Jumpstart was, then you should turn it mixed, right? Because in its simplest form is not leaving it improper. However, when it's ratios, you want to leave it as just a plain fraction, whether that's proper or improper. You just want to leave it as a plain fraction, right? And if it helps you to remember, you don't want to eat some weird candy that's some mix of a Kit Kat and M&Ms. You want to leave it as 10 M&Ms for every 3 Kit Kats. All right, makes sense? So for this chapter, or at least while we're dealing with ratios in this chapter, we're going to leave them as improper, and that's okay. All right. So let's look at a few examples here. So I'll give you a minute to get number 1 written down. 56 pencils to 64 erasers. This is a ratio, meaning that for every 56 pencils, you have 64 erasers. So, and these are nice because they really are as simple as this. 56 pencils to every 64 erasers. That's it. What's the matter? So the hardest part of this is simplifying. And you guys did an amazing job on the Jumpstart of simplifying. If nothing big jumps out at you, okay, and it might, something big might jump out at you. You might know right away that there's a bigger number that these both have in common. If so, great. If you're not sure, they're both even, which means you can divide them both by 2. And if you divide them both by 2, you get 28 over 32. And again, something big here might jump out at you. Great. If it doesn't, they're both even. So keep doing what's easy, right? Keep doing what you know until something big jumps out at you, or until you get to it's unreducible anymore. 28 divided by 2 is 14. 32 divided by 2 is 16. Okay, still reducible, right? It's still even, so they are both still divisible by 2. And you get 7 over 8. 7's prime, which means you cannot reduce this anymore. So that would be your simplest ratio. So what this means is that for every 7 pencils you have 8 erasers. Okay. Now, if you had known right off the bat, if you're great at multiplication facts and it jumped out at you right off the bat that they're both divisible, and I'm writing this backwards, please forgive me. I know that's a math, no. But if you know they're both divisible by 8, 56 divided by 8 is 7, 64 divided by 8 is 8. You would have gotten this right here. You would have just gotten it in 1 step instead of 3. It's fine. If you had gotten to this step right here and recognized they were both divisible by 4, great. You've gotten 7 over 8. Okay. Either way, anywhere along the way, whether you have to take it in small chunks or one big chunk, you still should end up with the 7 over 8. And if nothing big jumps out at you, go with the little ones. If they're even, they're both always divisible by 2. Remember the rule about how do you know if something's divisible by 3? What's the little trick? You guys remember? add up the, like for 56, add 5 plus 6. 5 plus 6 is 11. Is 11 divisible by 3? Then 56 is not. It's just a little trick. 4 plus 6 is 10. 10 is not divisible by 3, so 64 will not be either. So you can check the 3 rule. If they both end in a 0 or a 5, we know they're divisible by 5, right? So we can do that. If they both end in a 0, they're divisible by 10, and we can just mark off the zeros. So there's a few little tricks of how to knock some of these bigger numbers down until they get to something that is a little bit easier to handle, or until you get to the fully simplified version. Okay. All right. Let's jump down to the tenths to campers, because I want to show you when it doesn't just jump right out at you. I want to kind of talk about how we think through how to reduce these. So first thing we're going to do, you've got 26 tenths to 65 campers. So the first part, super simple, right? Just set up your fraction, 26 tenths to 65 campers. Okay, that's the easy part. Now we want to reduce. Well, 65 is not even, so 2's don't work. 2 plus 6 is 8, which 8's not divisible by 3, so 3's don't work. 26 doesn't end in 0 or 5, so 5 doesn't work. So kind of our easy ones that we always can go to really quick, they don't work. So the next thing to do is to try, you can try to take 65 and just divide it by 26 and see if by some chance it reduces like that, but this one doesn't. So the next thing I would do is I would take 26 and divide it by 2 and get the first factor to try. And I get 13 in my calculator. So now you have to see, because we know if we divide 26 by 2, we get 13, but 65 isn't divisible by 2. So we can't use 2, but let's see if we can use 13. So if you take 65 in your calculator and you divide it by 13, if you end up with a whole number, then it works. It's great. And here you do, you end up with 5. So that tells me that 26 is divisible by 13. I already tried that. And 65, I just checked, and it's divisible by 13. So when I divide 26 by 13, I get 2. And when I divide 65 by 13, I get 5. So it's just taking your smallest number, find a couple of factors of it, and then try those factors on the 65. And again, it's kind of like throwing darts at a dartboard. You don't know which one's going to work. You just have to keep trying ones until you find one that works. Okay. And sometimes it's not completely random, because sometimes there's a kind of a smart way to randomly check, right? It just kind of makes it a little bit easier. And finding factors of your smaller one sometimes make it easier to find factors of your bigger one. Okay. All right. You don't have to put this one in your notes. I'm just going to set it up really quickly. So 45 out of 75 days. So 45 out of 75. They are both divisible by 5. I know that right off the bat because they both end in 5. So if I take 45 divided by 5, okay, that means I've got to divide the bottom by 5. And when I do that, I get 9. And when I divide 75 by 5, I get 15. Now, since I just bit off a little chunk and I don't necessarily know if it's my biggest number, I need to think through, is this still reducible? Well, 9 is divisible by 3. That's the only number it's divisible by. So check to see, is 15 divisible by 3? The answer is yes, because 1 plus 5 is 6, and 6 is divisible by 3. So when we divide both of these by 3, we get 3 over 5. Those are both prime, so I know I have to stop, and that's my final answer. Now, again, right off the bat, if I had looked at 45 and 15 or 45 and 75 and thought, let me try 15. If you punch 45 divided by 5 and 75 divided by 5 in your calculator, you're going to get 3 over 5. So big chunk might work. If not, do the little chunks, okay? All of these so far have been proper, and that's fine. I want to do one example of when it's improper just to show you. Again, you don't have to put this one in your notes. We've got 25 calculators to 20 students. So we're going to set up our initial fraction, pretty easy, 25 over 20. They are both divisible by 5. I know that because one ends in a 5 and one ends in a 0. So I know I can divide top and bottom by 5. And when I do that, I get 5 over 4. 5's prime, so I know I'm done. That's my answer. And it's good to leave it as improper, because what this means is that for every 5 calculators, you have 4 students. So you want to leave it as a fraction that tells you your ratio of calculators to students. Okay. Are we good there? All right. That's the top half of your assignment. Pretty straightforward. Set up your fraction and then reduce it. Okay. It gets a little bit more complicated when you get to the bottom half of your homework. So I want to set up this. So go ahead in your homework and write down number 11, 6 pounds to 256 ounces. So the first thing I'll give you a sec before I start talking. 6 pounds to 256 ounces. And when you're setting these up, if you want to abbreviate, I am totally fine with that, as long as your abbreviations make sense. Okay. They don't even have to be the actual, real abbreviations that are standard, because for pounds, you can actually put LBS. If you don't know that and you don't want to use that and you want to put PDS or PA, I don't care. As long as I know it means pounds, I'm not going to get picky. So our fraction is going to be 6 pounds over 256 ounces. Okay. And you can abbreviate however you want to make life easy. Now, I cannot just reduce this because one is pounds and one is ounces. And it's kind of like comparing apples and oranges, right? You can't. You have to have matching labels in order to compare them. Which one is smaller, pounds or ounces? Ounces. So I'm going to convert everything to ounces, because I always want to convert everything to the smaller. So my goal in the end is to get pounds written as ounces and leave the bottom as ounces. Okay. I'll show you. It's a really easy way to do it. All right. So you're going to put another fraction on the other side of a multiplication sign. And I'm going to cross my ounces and my pounds top and bottom. So I'm going to flip flop it here. Now, what you want to do is you want to find a conversion that your biggest one is a 1. So let me show you what I mean by that. So we're doing pounds and ounces here, right? So let me go to this conversion chart. And yes, I am putting this conversion chart in the homework assignment. So you will have this. Now, there are a few conversions that are not on this chart, and I'll show you guys how to find that. It's pretty simple, but we want pounds and ounces. Well, it's right here, right here. So here's ounces right here, and here's 1 pound. Remember, I said you always want to find the conversion that makes your bigger one a 1, right? So pounds is my biggest. We found 1 pound equals 16 ounces. Everybody good with that? So I go back here and I say it's 1 pound for every 16 ounces. Okay, 1 pound for every 16 ounces. So now when I multiply straight across, I multiply my 6 and my 16. So 6 times 16 is 96. And then when I multiply across the bottom, 256 times 1, I keep my 256, which were my original ounces. And now I've got everything written in ounces. So now I can reduce. You cannot reduce until you get matching measurements. And this only applies when it's a conversion of some sort of measurement: pounds, pints, quarts, minutes, hours, miles, something like that, right? You're not going to worry about that up here. Tenths to campers. Can I convert tenths to campers? Right? Doesn't work. Can I convert pencils to erasers? No. So it doesn't apply when you're just comparing two things. But when you are comparing measurements, ounces, pounds, gallons, quarts, you can see them here, right? Cups, pints, minutes, seconds. That's when your conversion has to happen. All right. So now that we've converted, now we're just ready to reduce. Okay. So again, with reducing, if you don't know a bigger one, start with something small. Okay. If you want to try a bigger one first, it's very simple to try it. Like, let's just say I wanted to try, and I don't even think it's going to work. I'm just going to try. Yes. All right, let's try 16. So if I take 96 in my calculator and divide it by 16, if I get a whole number, 16 works. Now I do 256 divided by 16. I get a whole number. So I know that 16 works. Okay. So 16 works for the top and bottom. Now, if you just pulled that number out of nowhere and it didn't work, just go back down a little, try 8, try 4. If nothing else works, or you don't want to waste the time to try it, what can you always go to since these are even? 2, right? You can always divide by 2 if they're even. So you shoot higher, it might save you some time. This one, in this case, it does. So my fraction, when I divide 256 by 16, I get 16. And when I divide 96 by 16, I get 6. Okay, now it doesn't, just because you aimed high, it doesn't necessarily mean you aimed at the absolute highest as far as factors. So can we continue to reduce here? In this step, we divided by 16, which happened to work. If you didn't and you divided by 2, you divide by 2 and 2 and 2 and 2 and keep getting until you get to your end point. But I can still divide by a 2 here, right? Because they're even. And when I do that, I get 3 over 8. 3 is prime, so I know I'm done. I cannot reduce 3/8 anymore. And this was all ounces, which you don't have to worry about labeling it because I converted everything to ounces. It means for every 3 ounces, I have 8 ounces. Okay. Are we good with that? All right. Let's do number 13 here. We're doing gallons to quarts. So we're going to have to do a little bit of conversion, but that's all right. I have a conversion chart. So we've got 9 gallons to every 48 quarts. Okay. 9 gallons to every 48 quarts. Anybody know which one's bigger? Gallons or quarts? Gallons is bigger, which means I want to find a conversion that gives me 1 on my gallons, right? So my goal is to find a 1 gallon conversion to so many quarts here. So I'm going to go back to my conversion chart. Yes. Yep. And if you don't know, okay, just go here to this handy dandy conversion chart I found. And I found this online this morning. So it had most of them on here we'd need. It's got pints and cups and quarts. And so we're doing gallons to quarts, right? Well, right here is my gallons to quarts. 1 gallon to 4 quarts. So I go back over to my work and I know that for every 1 gallon, it's 4 quarts. So I plug that in and now, oops, it's not multiplies because we're converting. It's multiplication. So 9 times 4 is 36 over 48. So now that I've got them matching quarts and quarts, now I'm ready to reduce. Does anything jump out at anybody? Yes. Is 36 divisible by 8? Try. Well, let's try it. That's what we do. I mean, and that's what I want you to do. Punch 36 divided by 8 in your calculator. Comes out a decimal, so 8 doesn't work. What else? What? Let's try 6. So 48 divided by 6. Yeah, 6 works. 2 would work. 6 would work. 4 would probably work. There's a bigger one that works, but that's fine. I want to take it in chunks here. So we did 6, right? Perfect. So we're going to divide by 6 and divide by 6. And we get 6 over 8. And then because those are both even, I know I can go another step here. And I get 3 over 4. Am I good? 3 over 4, 3 is prime. I can't go any further. And that's good. 2 would have worked. 6 worked. That was a good one. 12 would have worked. Yeah. Yes. Yeah. So when you're done, you can go backwards and see what the biggest number would have been by multiplying all those red ones together. Yeah. But since you don't have that at first, you have to get it down first. And then if you wanted to see what the biggest number was to go backwards, like you said, you could look at your red divided bys and it would tell you that, right, 2 times 6 is 12. That means that 12 was your biggest factor. So if I divide 36 by 12, I get 3. If I divide 48 by 12, I get 4. Good. All right. I do want to do a seconds and minutes. Now that's not on your conversion chart, but I think you guys can handle this. So let's set it up first as our fraction. So it's 420 seconds over 10 minutes. Okay, that's our first step. And which one is, well, first, let me just do this. Let me put minutes up top and seconds on the bottom. Which one's bigger? Minutes. So I want my 1 on my bigger one. And then how many seconds is in 1 minute? 60. Good. Now I'm ready to convert all of this to seconds. So my top should stay 420 seconds. And now my bottom, 10 times 60 is 600 seconds. So I have converted minutes to seconds. Yeah, right off the bat, I can just knock those zeros off there. So right off the bat, I know it's 42 over 60. And nothing, just if nothing right off the bat jumps out at you, does anything jump out at anybody? If not, we're going to go with 2. Okay, so we're going to go with 2 because they're both even. So I know I can do that. 42 divided by 2 is 21. 60 divided by 2 is 30. Now what? Can I keep going? Yep, both of those are divisible by 3. How do I know? 2 plus 1 is 3. And 3 plus 0 is 3. So that tells me they are both divisible by 3. 7 over 10. Can I keep going? Nope, 7's prime, so I know I got to stop. So if at the 42 over 60, if you recognize that 6 was a common factor, great. You could have done 6 and still gotten 7 over 10. Okay, if you were some math whiz and figured out that 60 was the greatest common factor, great, do it in one shot. I don't know about you, but I would never have just picked 60 off the top of my head, but that's okay. All right. Yeah, and it doesn't hurt to try it. And if you think if 60 pops out at you from the very beginning, put 420 divided by 60 in your calculator and you would have gotten 7. No. If you see it right off the bat that 60 is an option, punch in your calculator and try it. You know, if you get, because you would have gotten 7 over 10, you would have avoided all of this right here in the middle. And that's fine. Take it in as short or as big of steps as you need to take it. Yep. And like you said, it doesn't hurt to try it. When Blake threw out 6 earlier, it just takes a second to punch it in and try it. If it doesn't work, try another number. Okay. All right. I do want to talk about inches to yards. So if we go with 4 inches over 3 yards, right? Yeah, so whoops, I keep putting equals because I need a conversion. This is going to be a multiplication problem. And I immediately want to flip and put yards up here and inches up here. And I want yards is bigger, so I want 1 yard. And then I need to know how many inches is in a yard. Now, if you know it, that's awesome. Okay. There's 12 inches in a foot. There's 3 inches or 3 feet in a yard. So there are 36 inches in a yard. But do I expect everybody to just pop out a conversion? No. So I will show you this. Go to Google and type in how many inches in a yard, because you want the 1 to be with your bigger one, right? So how many inches is in 1 yard? And it tells you right here, right here. There are 1 yard equals 36 inches. Take that back to your paper and put a 36 right here. Now, do I know that you could put, what's the conversion of 4 inches to 3 yards? Absolutely, but you don't get the credit if you just write the answer. So I need to see this fraction right here where you did the conversion, and then I need to see equals. And now remember, we got rid of the big one, so we got rid of yards, and now everything is in inches. So 4 inches, 3 times 36 is 108. And now that we have inches and inches, now we're ready to reduce. Okay. We know they're both divisible by 2. You might check to see. Yes. Perfect. So if you want to just check it, just to see if maybe it works, take 108, divide it by 4, comes out to 27. So that's awesome. You know that we can do a divided by 4 and divided by 4 because it did happen to work out when you tried it, and you got 1 over 27. And of course, once you hit a 1 anywhere, you're done. Okay, so 1 inch to every 27 inches is our conversion. All right, are we good? Doesn't matter. Seconds to hours would be very similar to that whole inches to yards. It goes seconds to minutes to hours, right? You got to kind of make two jumps. Okay. 60 seconds in a minute, 60 minutes in an hour. So it'd be 60 times 60. Okay. So a lot of seconds in an hour. Huh? Did you just do that in your head? 3,600. You did 2 times 6 instead of 6 times 6, but I saw where you were going. You had the right idea. All right. So again, you just want to set up your conversions. For those of you at home, if you have any questions, shoot me an email and let me know if you have any questions.